Hello students and welcome to another video. Today we're going to be interpreting chemical equations. Right? And the equation that we're going to be looking at and examining in depth today is nitrogen and hydrogen combining to form ammonia. Okay, and we're going to go through and break down and further and help us understand, because this is a balanced equation. Okay, we see that hydrogen has a coefficient of 3 and ammonia has a coefficient of 2. We can tell that everything looks good in this equation. It's balanced on the left and right sides. Okay, that was basically what we learned in chapter 6. And now we're going to add information to this. We're going to give it a little more context of understanding the quantities needed to make these products and how much reactants we need to form to make ammonia, okay? And that's what stoichiometry is. It's the calculation of quantities and chemical reactions. All right, I want you to write down this definition. If you need to pause the video, go ahead, pause that now. Write down the definition, put it in your notes. Okay, we're calculating the quantities in chemical reactions. So if we come down here, I just want us to appreciate this picture down here. So we have our reactant. It's dinitrogen and dihydrogen. These exist as diatomic molecules. Okay, we should know this by now. All right. And we basically need 2 nitrogens for every 6 hydrogens to make ammonia. Okay, so our reactants and our products balance out because we have 2 and 6, and we have 2 and 6. All right, but when they combine, what they really look like, because nitrogen and hydrogen are diatomic, okay, these will exist as one entity, and these will exist as 3, not 6 and 2, because they exist in pairs. They're found in nature like this. So we're going to have 3 molecules of hydrogen for every molecule of nitrogen. So there's a ratio there. We need 3 to 1 as far as hydrogen to nitrogen. And then that forms 2 molecules of ammonia. So we have a couple different ratios going on. We have 1 to 3, 1 to 2, 2 to 3. So there's different numbers of reactants and products that are being formed. All right. And if we look at this in the terms of moles, for every 1 mole of nitrogen, I would need 3 moles of hydrogen, and I would create 2 moles of ammonia. Now, don't get tripped up with mole. You're like, okay, I'm forgetting what that term is, right? You're struggling to understand. It's a counting measure, okay? It's just like a dozen. I need 1 mole, that large number of that substance, okay, of nitrogen. If I had 1 mole of this, I would need 3 moles of hydrogen. I need 3 times as much hydrogen than I would nitrogen to be able to make just 2 of these ammonia molecules. All right, and because we know that hydrogen and nitrogen, they are different atoms, so they're going to have different masses. Nitrogen's a lot bigger. Okay, so if we have 2 of them, we're going to form 28 grams. And if we look at our periodic table, let me grab one here. Okay, our nitrogen is 14.01. That's its molar mass. But because it's existing in a diatomic molecule, we have to multiply it by 2 because there's 2 of them. Okay, so that's going to be 28 grams. All right, and hydrogen is 1.008. And in this problem, they simplified it, but there's 2 of them, so there's 2 grams. So our total reactants, if we had 1 mole of nitrogen and 3 moles of hydrogen, it would weigh 34 grams. Now, we have to double check this, because if that's how much it weighs on this side, totally between nitrogen and hydrogen atoms, how much does it weigh on the other side? Well, NH3, okay, it has a average atomic mass of 17.0 grams. That's how much this ammonia weighs, but there's 2 of them, and that also equals 34.0 grams of product. So this balances out as far as in terms of stoichiometry, because we're looking at the quantity of the substances, and that is in both moles and masses. Okay, and the masses now balance. Okay, our moles are basically showing us a ratio. Okay, they won't always equal each other. Do you see how this one's 2, 3, and 1? They're all different. It's because it's showing you the ratio. This is showing you in grams the balancedness of this equation because of these ratios up here. Okay, it takes practice. Me explaining this isn't going to be enough. You're going to have to do the practice problems, work through it to understand what is happening. It's going to take multiple attempts to get this concept. When you come back to review this video, it should make a lot more sense after you've done some practice. Okay, and ignore the volumes. Okay, in this introduction course, we don't talk about gas laws. If you want to learn about gas laws, go take a chemistry course at college when you go there. Okay?